Hands-on, feet on, powered on your mark. On is the start of everything. On is the key to learning. Being on an environment, not just in it. Being on the world, not just of it.
Tarquette understands how important On is.
We work on it every day. On the ground with you, designing flooring experiences to grow on, dream on, and get on with it.
So today we're going to talk about a big topic in school facility planning, which is the topic about STEM. And we've seen that there's sort of been a range from, districts or schools starting in the planning phases on figuring out how to implement that into their existing projects or schools, and all the way up to those schools that have actually built environments. So today we'll kind of be talking about why it is so important and how we can better design spaces to support our students. Just a few learning objectives. And so STEM, STREAM, STEAM, PBL, NGSS, what do all these acronyms mean, right? So we'll kind of be going through that, also talking about through some case studies, some successful STEAM spaces and how that differs from traditional classroom environments, and how some of the things or tips that we can future-proof these built environments so that they can be continued to be used by students of today as well as the future, and any key design features for these projects. So today's presenters is myself. I am a project manager as well as an educational facility planner at LPA in Irvine, California. And we have Emily Coach, a project designer in LPA, Texas. So what is STEM? STEM, again, it stands for science, technology, engineering, and math, and I'm sure many of you already know that. It is an interdisciplinary approach with a blended learning type of environment with a focus on the science, technology, engineering, math components. So the real focus really is on real-world application and problem solving, as well as critical thinking. Activities of these may be projects, but they don't have to be, and it's sort of flexible and a little bit easier to implement than PBL. Project-based learning, which is also similar to STEM, is learning through the use of projects and problem solving. It includes elements that raise the level of learning into that deeper learning that we're all striving to achieve in the project. They also tend to be student-driven with choices. They focus on how to work on projects, and then after completing a project, students will present their findings. Now, and then STEAM here adds the arts into the science, technology, math, and engineering, and then STREAM, in addition to that, also adds the reading and writing component to that. So why has STEM become a big topic, and why are so many schools sort of implementing it? So it kind of stems from the whole Common Core standards that were adopted now a few years ago now, and with a greater focus on really conceptual understanding of topics versus just rote fact memorization, and really linking those topics and to applications as well as real-world learning experiences. Similar to this approach is the NGSS, which is Next Generation Science Standards. And as you can see, many of the states have also implemented that. Approximately 20 states, or 36% of the US students, have adopted NGSS standards. And these are really focused on skills-based, evidence-based reasoning. Students think and reason and connect subjects to core concepts. Now, the Next Generation Science Standards sort of set the goals for the next 20 years for science education. The focus, again, like I was saying, was inquiry, engineering-based with deeper understanding and real-world practice rather than facts only. This translates into knowledge into applied situations. It also integrates science and engineering into curriculum, even at the earlier elementary levels, and it's no longer just a focus on K through 5 with language, arts, and math, but also integrating science and engineering in there. So it's quite important that these are sort of integrated into the whole curriculum of not only higher education as high school and middle school, but as well as elementary school levels. So, so a vision for STEM education. In December of 2018, the White House's a report was published by the White House's Committee on STEM Education of the National Science and Technology Council. And this published report was America's strategy for STEM education, with the vision that all Americans will have lifelong access to high quality STEM education, and the United States will be the global leader in STEM literacy, innovation, and employment. Essentially, it's the US federal government's 5-year strategic plan for STEM education. You know, the goals of this plan will be to build strong foundations for STEM literacy at all levels. Also, there's a great focus on targeting underrepresented minorities in the field, including women and specific ethnicities, as well as preparing the STEM workforce for the future, since that's where a lot of the growth in jobs have been. Some of the pathways to achieve these goals, including partnerships or increasing partnerships with education institutions, with employers, as well as communities, and providing those internships and apprenticeships for students so that they can practice what they learn. Also, providing real world challenges that require creativity and empowering students with digital literacy. So why is STEM education so important? So these graphs here kind of were published by the US Bureau of Labor Statistics, showing that the state of STEM fields in the United States. So as you can see, in 2015, there were approximately 8.6 million STEM jobs, about 6.2% of the US employment. Since 2009 to 2015, California itself added nearly 160,000 STEM jobs. Between 2009 to 2015, STEM occupations grew by about 10.5%, which is approximately 800,000 jobs, compared to a 5% growth in non-STEM occupations. And the projected new jobs for STEM occupations between 2014 and 2024, this is just when the study was done, it was projected to increase by 12.5%. So it's approximately 500,000 new jobs in the STEM fields. And then the STEM fields sort of, as you can see here, the greatest number of jobs being in the computer-related field. So, so research provided by Wayfind Education, whom we work very closely with, indicates that there's a critical challenge to education or school education. And this is a 2016 study, and the blue line indicates students that indicate in the last 7 days have learned something interesting at school. The green line is indicating they had fun at school, and the red line is indicating at the school they got to do the best they could do every day. And as you can see, from the 5th grade through the 12th grade, there is a decline in these numbers. And so, you know, this is an issue, and this is the reason kind of why students sort of need places that activate sustained engagement. And what is it that something that can create that spark or their interest in learning, or create that aha moment that, and it's at those times in which students will really learn the most, but also what they learn will actually stick with them through life. And that's the deeper learning that we're all kind of trying to seek. There really has been a culture shift in education, really from a culture of school as we've known it to be, to really a culture of innovation, and really developing the workforce to more innovative critical thinkers versus just knowledge, those who just know technical skills. And it really requires a shift in the mindset, and some of the really important things are developing collaboration skills, and an experience of interactivity and connections that the student can make during their school days, or where they're learning, as well as multidisciplinary learning versus specialization. More of a trial and error, and that growth mindset versus, risk avoidance, and, a culture of creativity and intrinsic motivation, and learning through play. Okay, and this slide sort of kind of talks about how letting research really inform our space design. So how is all of that, we know the importance of deeper learning, how to better engage students, but how can we translate that to built environment and space, and how can we create spaces, especially spaces of belonging, students going to school and feeling that they belong there, and obviously built in like curiosity. How can we spark those aha moments, as well as purpose, real world experience and applications, building in spaces that can facilitate a collaboration and connections between students as well as teachers, or community, and then connection with family and the community, and building spaces that are not only that sort of foster these characteristics, but also having collaboration, flexibility, and connectedness also in mind. So spaces of belonging, what do those look like, and how can those sort of translate into some of the spaces that we're designing and creating for students? And with that, I think I'm going to hand it off to Emily, who's going to go through a few case studies of some projects that we have implemented STEM spaces successfully.
Yes, our first case study is Eastvale STEM Academy, which is a high school that recently opened in Corona Norco, which is in Riverside, California, in the Inland Empire. This is a 1,000-student high school divided into 2 STEM academies, one engineering and design pathway and one health medical pathway. We had a really robust planning process with this project. That is what made it so successful. And this process lasted 2 months and was divided into 4 different sections: involving discovering the specific needs of the community, collaborating together, exploring, and then researching, getting really to the heart of the student and the characteristics of the student. The discovering process brought together a really large group, over 50 members, including local community, business members, community colleges, and really getting to the why of the project. Why STEM, which we covered in the previous slides, and then specifically why engineering and design and health medical pathways, which really grew out of the local community colleges, what they were seeing students looking to major in to get into the local job market. This is a timeline that shows that 2-month process at the beginning of the project, and all the workshops we did, confirming the learner profile, collaborating together, the preliminary programming. We did a lot of tours with this group to look at what else people have been doing out there in STEM environments, and workshops, all to create the ed spec and the program document that was the basis of the design. Under collaborating, we did a lot of workshops with this group that really got to who are the learners and getting people out of their perspective that they bring to the table, which is important, but also getting them to empathize with the future students. So this really helps with future-proofing your STEM environment because it takes people out of their day-to-day and what they know and their current problems and gets them to think about someone else in the school and someone else's future. So we did that through the persona exercise, giving people different students or teachers to be, and then having them walk through a day in the life and experience mapping. So it really got to what spaces are the engineering academy using, what spaces are the biomedical students using, and where do they come together to feel like they belong together as a whole school. Under the research phase is when we went on lots of tours with this group, and we had them write down sort of their thoughts at the time, which was really helpful data collection for us when we went through the design process because we had lots of notes to go on of what things were working and what things didn't work. So I really recommend when you go on a tour to have people also write things down and document those thoughts in time because it can be really easy to forget all the great things that you saw. In the explore phase, we got to the heart of the matter. We did this exercise where we asked our group to really understand who are the learners and what are the qualities they want the learners to have when they graduate. And that really helped our group understand how the space needed to change in order to support a new type of instruction that'll have our students be passionate and persevere, be purposeful contributors, be inquisitive problem solvers, ethical risk takers, and effective communicators and collaborators. And all of that translated into our design, which you can see here. In the orange is our Health Medical Academy, and the greenish color, greenish gray, is the engineering and design. And we have in the blue our labs and studios, which we'll get into more detail in the next slides. So we used a kit of parts for this project for diverse learning spaces. The letter A here are what you would most closely call like your classroom space. We call them learning studios, and each learning studio is connected with a movable wall and has a spark tank for small group or individual work right off the classroom for breaking out. The B prototype is the learning studio, which is a little larger and connected, and each B has a outdoor learning courtyard connected to it to break out into nature, which can help creativity, it can help spark ideas, and is, especially in Southern California, just a really nice place to be that the students and teachers enjoy. And then our C learning studios are closely most like science labs, where we have the more upgraded lab type of casework and countertops in order to get to those really scientific experiments that need to happen. And here's another example slide showing those prototypes. And we actually did a post-occupancy evaluation on all these right after the pandemic hit. And so students had had just about a year in these spaces and then had transitioned to working from home. So I think that increased their satisfaction ratings. You can see perhaps they missed being at school. And so in little stars there, you can see their satisfaction. This is a view of one of the student collabs. All of the learning studios are off of these interior collabs, as well as some outdoor courtyards that help increase student collaboration together. And one thing they've really pointed out that they love is having so much writable wall surface. As you can see the students here writing together, they're using Post-its and tacking up their work. A student union space is really important to increase that sense of belonging that Jomei talked about. It helps the students promote dedication and hard work, as you can see from our post-occupancy survey results there. This is a view of the biomedical health pathway. and having that space for all of that specific equipment. They appreciate having that hands-on physical thing to help really have that learning stick with them as they go on to their college and career. And then space for inspiration. We included and incorporated visuals throughout that really helped make this space feel like it was meant for STEM. You can see we added little details like the periodic table. The Hello World sign is actually code, computer code for the engineering and design pathway. And students at the school actually did a charrette with us and helped come up with these graphics. And being a high performing building with 62% energy reduction and all these sustainable strategies that are put on display with things like exposed utilities throughout that help the students understand how the building was designed as they go off and become future engineers and designers themselves. An outdoor space, as I mentioned, being out in nature can be really important to inspire creativity as well as just relaxation and coming together as teenagers need to do. The outdoor space is very popular with students and teachers. You can see 87% of students said that the outdoor space is valuable or extremely important to them. Another view of that quad space. And the students love having that amphitheater to gather together and sit together during lunch. Our next case study is at the middle school level. This was a recent project we did for Alamo Heights Junior High. You can see they have some planter boxes for a little garden here outside the new building. Three big ideas that we talked about during the planning of this process were connectivity, having lots of transparency and interdisciplinary interaction between spaces so that that design thinking and learning is on display. Agility, agile spaces are adaptable, fine-tunable, and technology-enabled, and inspirational, similar to those graphics in the previous project. So this is the floor plan, a two-story building. They needed traditional science labs as they know them, and then they supplemented their program with these more flexible STEM lab spaces, which you can see in the green, and then having a learning commons on each floor as well for that student collaboration. This is one of those STEM labs, and you can see the dividable wall really helps if they have small groups or if they want to do one teacher, team teaching, two larger groups together. And then the next slides will go into sort of the qualities of the space that really help make it flexible. You can see we included overhead power. We kept the built-in bulky utilities on the perimeter, so perimeter casework and storage. Mobile furniture helps keep that floor space clear and able to change and adapt to differing programs, different group sizes, different projects or problems, and then having mobile storage as well. Another view showing all those same qualities. And here is a photo of students in the space, each working individually here. Outside the classrooms, we have a lot of visibility into the space with the glass, including some graphics and identity, showing that this is a place for STEM. Collaborative seating and writable walls again. We included storage in the hallway because no space ever has enough storage, tack panel, as well as the writable wall surface, and this built up seating or display platform that they can show their work. Here's some students using that display platform to collaborate. We also included a larger shops type of space on the ground floor with these large transparent garage doors so they can wheel their work and projects outside. Clear floor space with mobile furniture, again, including overhead power. And in this space, we included a unistrut grid that they can adjust that power over time. to adapt to changing equipment. Here's some of the larger pieces of equipment. And you can see the roll-up doors, not only on the outside, but roll-ups on the inside to connect larger spaces. And then lastly, I have an example from higher education. This is the Los Rios Community College Natomas Center. And we worked with HERA lab planners here who felt it was really important to use a collaborative style layout in each of the science labs. So you can see from this diagram how just tilting the traditional lab setup, which is very orthogonal and everyone facing forward, giving a slight angle and rotation allows each student to not only see the teacher, but also each other. So it increases that collaborative nature. And when you bend just an arc on each lab table, it again increases that collaboration by having students look not just at the side profile of each other, but see more eye to eye and increase discussion. So the floor plan of this building included computer and tech labs and regular classrooms on the first floor, as well as an art studio and some administrative program is in the purple. And all of the science labs were located together on the second floor for ease of utility access, with a very large, long prep lab that connects all the labs. And so the faculty have a very large space that they can collaborate together. And it's not divided where, they have to go into separate prep rooms. So they're all together. One thing that was really important to this client was having space for students to gather and collaborate, because that's currently missing on their campus. And so having this collaborative space for students to be together will help increase their sense of belonging. Another view of their collaborative space. And on the second floor, we included spaces for more quiet study, as well as spaces for bigger groups to gather. Another quiet study space, again showing using whiteboard spaces on the wall in connection to nature. This is a computer lab on the ground floor, and one of the science labs, as you can see, that rotated lab table and a view of the large prep space. You can see ample storage, again, using the same principles of flexibility, even though it's packed with all the stuff that they need. We have utility at the perimeter and mobile storage, mobile furniture, and writable walls. And that's all we have. Thank you so much.